So in that last one, there is no saddle point. If there's no saddle point, then the players won't just choose one strategy and stick to it. It's not in their interest to do so. They all want to play different strategies, different proportions of the time. Before we looked at a pure strategy game, that was when there was a saddle point. What we're coming on to now is what's called mixed strategy games. So mixed strategy games, and what we're going to look at first of all is just for 2 players, so we're getting a 2x2 matrix. So the next example, if I give you another matrix to consider, it'll be 2 players, 2 strategies. Let's keep it simple to start with. First thing we'll do is a minimum across each row, and then we'll choose a maximum. Then we'll do the maximum for each column, and we'll choose a minimum. And because the circled numbers are not equal, we don't have a saddle point. So that means X will not just stick to strategy 2, Y will not just stick to strategy 1. They want to play both strategies. So what we're going to do now is work out what proportion of the time X should play strategy 1 and should play strategy 2, and similarly for Y. So we need to first of all put some probabilities on here, and we'll have X plays strategy X1 with probability P, and X plays strategy X2 with probability 1 minus P. And we'll define for Y as well. Y will play strategy Y1. Well, we'll have a look at that bit in a minute. Actually, we'll move on to that bit in a minute. Let's just look first of all at if Y plays Y1. Let's just see what will happen. If Y plays Y1, what we want to look at here is X's game. X is the offensive player. If Y plays Y1, X will get a profit of 4 for proportion P of the time, and X will get profit of 3 for proportion 1 minus P of the time. If I add those expressions together, I will get the expected profit for player X. If you multiply the brackets and simplify, I've got 4P there minus 3P, and I've got 3 times by 1. So if player Y plays Y1, X can expect a gain of P plus 3. What we need to look at now, again with X as our focus, but what's going to happen if Y plays Y2? So we're looking at this column here in the matrix. Remember, X is going to play this strategy, X1 with probability P. So again, X's gain will be 2 with probability P, and will be 10 with probability 1 minus P. And if you multiply out the brackets of there, you've got a 2P and a minus 10P, which is minus 8P, and 10 times by 1 is 10. You get those two figures. And these are like the worst things that can happen to player X. So if we let V be the value of the game to X, we know that V has got to be, well, can't exceed these things, because these are the worst case scenarios. So V will be less than or equal to both of those values. And what we want to try and do now is find what P value will make that maximal for player X. So what we do now is we graph those two equations. So if we just draw a little sketch graph of those, along the bottom we're going to have P, which can only go between 0 and 1. Then up the top we'll have our value. So we've got equation 1 and equation 2. When P is 0, what's the value of P? In equation 1, imagine these are equal signs for a minute. If P is 0, what's the value of V? P is 0.
3.
Sorry? Yeah, so here I'll put a point of 3. When P is 1, what will V be in this first equation here? 4. So I'll put a mark at 4, and if I join those up, that corresponds to equation 1. The next one, the second one, if p is 0, that is 10, and if p is 1, that falls to be 2. So we get that line for equation 2. And we've said that the value has always got to be less than these two things, less than both of them. So that shaded area represents a part of the graph we're interested in, and what we want to do is maximise that. We want to maximise the value, and the maximum value is going to be at this point here, where these lines intersect. So if I can work out that p value, I will find my maximum v value. The best thing for x to do will be to play strategy 1 with this p value here. So how do I find the p value that does this? Well, it's where these two lines intersect. So what I need to do is put those equal to each other. P plus 3 equal to 10 minus 8p. And if I solve that equation, I will find what value of p I need. So if I shove that 8p over here, I'm going to get 9p. And shove that 3 over there, I'm going to get 7. So p is 7/9. So for this game, x should play his strategy 1, x1, we said with probability p, so that's going to be with probability 7/9, and x should play x2, we said 1 minus p, so that would be 2/9. So we've worked out now what proportion of the times x should play each of his strategies. I'm happy with that. So if we look at this now from y's point of view instead, from y's point of view, let's say that y will play strategy y1 with probability q, and will play strategy y2 with probability 1 minus q the rest of the time. If I get the matrix we're looking at back again, which was here, well, y has to think, well, what will happen if x plays x1? If x plays x1, which is along here, y will get a profit, or y will lose 4 with probability q, and y will lose 2 with probability 1 minus q. So if I add those up, they are y's losses. So what I'm going to do is put those inside a bracket with a big minus sign, because they are losses to y. And if x chose to play strategy x2 instead, we're going along here, y would lose 3 with a probability q, and y would lose 10 with a probability of minus q. Add those together, they are losses, so put a big minus sign there. These minus signs are important because they're losses. If you multiply all this out, get rid of the brackets and everything else, this line becomes minus 2q minus 2. This line becomes 7q minus 10. And just as we found out what x should play by equating those, if we equate these two equations over here, we can find what value q is, and then we can recommend what proportion of the time y should be playing strategy 1 and strategy 2. So if you move that 2q over here, you get 9q. If you move that 10 over here, it becomes a plus, we get 8. So we get q is 8/9. So that means y should play strategy y1 8/9 of the time, and should play strategy y2 1/9 of the time. Now if we just go back to work out the value of the game to each player, we've said before for player X, these expressions here were the value of the game. We said for X, P was going to be 7/9. So if I substitute P equals 7/9 now into these, the value of the game is going to be 7/9 plus 3, which is 3 and 7/9. Or if I stick this 7/9 into this one, I'm going to get 10 minus 8 lots of 7 ninths, which is going to be 10 take away 56 ninths. And if you work that out, that will also come out to be 3 and 7 ninths. It should give you the same value. So the value of the game to x is 3 and 7 ninths. What should the value of the game to y be then? Yeah, and you can check. So that if you now stick that q value of 8 ninths into either of these, well, let's stick it in this one, it's easier. 7 lots of 8 ninths minus 10. Looks like James is going to bang that into a calculator for us. 7 lots of 8 ninths minus 10.
Minus 34 over 9.
Can you give that to us as a not top-heavy fraction?
Would you say it's the minus of that last answer?
We are hoping it would be, yes. It should be minus 3 and 7 ninths. Will you stop recording there?